Good morning, Technical Science Grade 12 learners. I am Mrs. Malahlela. Today we are going to do the exam preparation for paper 1. Since you'll be writing on Friday, so we're going to highlight some factors which leads you to forfeit the marks during the exams. But before we start, I just want us to talk about the documents that you received that the Free State Department of Education prepared for you. If you use those documents optimally, it is guaranteed that you will be able to get good marks on the paper on Monday and also on Friday and Monday for paper 1 and paper 2. So I'm going to start with the exam guideline. The examination guideline, it is a document that each learner must have. Inside the exam guideline, it is going to help you to pay attention to the important factors or the important facts that you must pay attention to, that you need to learn so that you are well prepared for the final year exam. Now, this document, it is so important. It is only for mechanics, and then we have summaries of the topic, the terms, the definitions, the question, and the answers per topic. So if you use this document, you will be able to get marks. The first challenge that we normally facing with physical sciences, it is the conventions. Our learners are struggling with the conventions. So here are given the conventions on this document. So you will be able to just go through this so that Newton's first law. This is the topic that is being given. So you will have the summary of the topic where it is given, where you will know that for the Newton's first law, this is what I need to know, and also what is happening with the structures also, and also in other topics there are also the flow diagrams. So now there are also definitions. These definitions are also taken from the examination guideline, and it is important for each learner to know how the definitions, learn them, know them by heart, because you might get plus or minus 20 marks only on definitions before you even attempt to answer the long questions. And then for each topic, we also have the multiple choice questions. So please go through this. After multiple choice questions, we also have the long questions these questions, they are so different, so you are able to have a variety of questions that you can work on. Now at the back, that's where you are given the answers for the questions that we just took a look at. Now please use this document optimally. So I believe that you have this document next to you because we're also going to use it with you today. So I am going to start with the exam preparation. So last time we did Newton's laws of motion and also momentum. So now today we're going to start with work, energy, and power. So with work, energy, and power, firstly, you are expected to define work. So by defining work, we know that from the table of formulae, you are given the formula W is equals to F. You are given W is equals to F delta X cos theta. So with this formula, if you forget how to define the formula, the term work done in the exam, just go to the formula and it will help you, because now it is the product, because we are multiplying the product of the applied force on an object and the displacement in the direction of the force. So let's take a look at the formula again. Work, it is the product because we multiplying F and delta X. So it is the product of F applied and the displacement in the direction of the force. That is how we define the work done. Now, you must also remember that work is a scalar quantity. So because it is a scalar quantity, we know the definition of a scalar quantity, it only has the magnitude. So it means we cannot choose the direction for work done. But now because we have a cos theta in our formula, then the theta, it is the one that will determine whether we'll have the positive work done or the negative work done. So remember, for a scalar quantity, you don't choose the direction. So we use the formula to calculate work. W is equals to F delta X cos theta. And then while we know that for F, we know it is the force applied. So it can be any force, frictional force or applied force or gravitational force in case we have it. And then from the formula again, you need to know the SI unit for work, which is joules. So we don't write it in full. We use a symbol capital J. And learners, please be careful. Every time when you write the units, make sure that we are able to see what is written on the script. And then moving on. Now for theta, we always represent the direction of the applied force. Then we also know that work is not done when the force acts at right angle or perpendicular to the direction of motion. For an example, if the object is moving to the right, and then we know that we must identify the forces acting on an object. So those forces, if the force is perpendicular to the direction of motion, then we know that the work is not done. Then before you attempt to do any calculation, please try to draw a free body or force diagram so that you are able to identify the forces that are doing the work and the forces that are not doing the work. And it will also help you to identify the negative work, whether we'll have the negative work done or the positive work done. And while you're still with the drawing of the free body diagram, please pay attention that every time when you are asked to calculate work done by frictional force, you must always make sure that cos theta equals to 180 degrees. Because, why am I saying this? It is because now we know that friction opposes motion and acts parallel to the surface. So when it opposes motion, it means it cannot have the positive work done, but it must have the negative work done. So I'm going to repeat that again. With work done by frictional force, you make sure that the theta, the magnitude of theta, it is always equals to 180 degrees. That shows that friction is opposing motion. Then we calculate work done. Sorry, work net. Now we're going to go through the calculations. Some of the examples from the terms and definitions booklet. So what we're going to work on now, on page 27, let's do question 2. When you're doing the question again, the approach that you are going to use, it is also important because now learners tend to omit some of the keywords. So what we normally advise the learners is that when you try to read the stem that is given, make sure that while you read, you underline or you highlight what you think is important. For instance, you are given a 5 kg crate that is at rest. So this weight that is at rest on a frictionless horizontal surface. So the words that I just highlighted are going to help you to answer the question, because now we are given the mass here. You are told that the crate is at rest. So what does that mean? It means that the initial velocity is equals to 0. And on a frictionless horizontal surface, what does this mean? It means now there is no friction, because the word frictionless means that on the horizontal surface, there is no friction. And also it says the crate is then pushed by a constant force F. So this is the constant F force that is given. It is also the word pushed. What does it mean? That means that now the force is acting at an angle. And the magnitude of that force is 10 newtons, acting at an angle of 30 degrees to the horizontal. Now the crate moves a horizontal distance of 2,5 meters and reaches point B. Where is point B? Here is our point B, and reaches point B at the end of the surface at a speed of So now you have the second velocity. So now you have the initial velocity of 0, and also it started from rest, and then now it moved at a speed of 2.94 meters per second. Then when the force is removed at point B, the crate falls at a vertical distance. So now we have the vertical distance where the crate fall, distance of 0.44 meters to the ground. Now you have all the information that is given. So the next step, it is for you to write your data. Remember, I know that your teachers did teach you how to collect the data. So you're going to write your data. What is it that am I given? I was given the mass of 5 kg. So writing the data also will help you with the conventions in cases whereby we know that the SI unit that we use for mass, it is kilograms. So if the mass is given in grams, then when writing down the data, it will also help you to convert, to ensure that you have the correct SI unit for the physical quantities. And then we have the initial velocity at 0. We also have the F applied at 10 newtons, and then we have theta. This is the information that is given. I haven't even read the question yet. And then we have the final velocity up to point B. So you must be careful with that one, up to point B, which was 2.94 meters per second. And then we also have the height of 0.44 meters to the ground. So this is the data that you are going to collect. Then the next step, you read the questions. 2.1, define the term work for 2 marks. We cannot afford to forfeit this mark, because now we know that if you forget some of the words, because we use the keywords, if you forget the keywords or you omit the keywords, you will be penalized when we mark. So what we want you to do, write down the formula so that you always remember, or refer to your table of formulae that is given to remember what is the term, how do we define the work. And then 2.2, calculate the net work done on the crate as it moves to point B for 4 marks. So before you do the calculation, just draw a free body diagram, and then with the free body diagram, you'll be able to tell us how many forces are doing the work, and then you calculate work done by each force. Then after calculating work done by each force using the formula, the correct formula that is being copied correctly from the table because it is given, then you'll be able to get that 4 marks. Then moving on to the next question now. For each and every question, make sure that you have the correct wording and you're using the correct information, you're using the correct formula, you copy the correct formula, you don't omit some of the physical quantities because you will be penalized. So now we're moving on to the conservation of energies. So with the conservation of energy, number 1, we know that the energy is defined as the ability to do work. And also the SI unit that we use for energy is the same as the SI unit for work done, whereby here we're using joules or capital J. Then, when we are dealing with conservation of energies, you must always remember that now we are dealing with the actually it's 3 types of energies. We are dealing with the mechanical energy, and from the mechanical energy, we know that the mechanical energy is the sum of gravitational potential energy and kinetic energy. And we use the formula ME is equals to, ME stands for mechanical energy, is equals to EP stands for gravitational potential energy plus EK for kinetic energy. And then after knowing the mechanical energy, then we move on to the principle of conservation of mechanical energy. So the principle says that the total mechanical energy in an isolated system is conserved. So isolated system means that there are no external forces acting on an object, which means the net external force will be equals to 0. So the system is conserved. So guys, what is important here? You must always remember that when the object is moving from top to bottom, the object will be having the mechanical energy. Let me make an example here. Let's say we have a ball that is being thrown from rest, and the ball will move to the ground. So, sorry, my pens are not right. That will move, that will be thrown to the ground. So what is important, now we will have point A and point B and point C. Remember now, as the ball is falling downward, for each and every point that the ball is passing, it has the mechanical energy. So because of the conservation of mechanical energy, it means at this point we have the mechanical energy, at this point we have the mechanical energy, and also at this point we have the mechanical energy. So we know that mechanical energy is equals to EP plus EK. So now we can say, because we are now dealing with the conservation of mechanical energy, we can say the mechanical energy at this point will be equal, must be equals to the mechanical energy at this point, and also at that point. So the mechanical energy at each and every point is the same. Now, from there, after knowing that, we know that now we are dealing with the mechanical energy between 2 points, the initial point and the final point. Now, at this point, we now, when you take a look at this, we have the height, which means the velocity will be equals to 0, and we'll have the certain height at point A. But at point B, because now the object will start to move. Remember, the principle of energy says energy cannot be destroyed or created, but can be transformed from one form to another. So because the velocity was equals to 0, that means kinetic energy is equals to 0. So at this point at rest, at the top, at point A, we only have the potential energy. But now, because of the height, but now at point on the ground, let me call it point D. Let's say we have point B and point C here. At point D on the ground, the height is now equals to 0. So the moment the height becomes 0, it means EP is equals to 0. And then, because the object now has moved from point A to point D, the velocity has now increased. Now we'll have the magnitude of the velocity on the ground. But not forgetting that at each and every point given here, the mechanical energy is the same. Now, from point A, as the object starts to move, that means now the velocity is now being, the potential energy is now being transferred to kinetic energy, because as it moves downward, the height decreases, but the velocity increases from top to bottom. Okay, now going back to our presentation. Now, you also expected to define the isolated system, whereby it says the net external force acting on the system is equals to 0. Then we use a formula here to calculate mechanical energy initial equals to the mechanical energy final. I know this formula is given, and I also know that EP is equals to mg and EK is equals to half mv squared. learners, you must be careful. What is it that you are asked to calculate? So we tend to find that learners, when they asked to calculate the final velocity on the ground, when they were supposed to use the conservation of mechanical energy, they will just use the formula for EP is equals to mgh, forgetting that at each and every point there is a mechanical energy, which means we have the sum of both EP and EK. So the moment you only use EP and do not calculate EK, you forfeit the marks, and you'll find that the learners will get 0 instead of getting full marks. So it is always important, use the booklet for revision. Just do almost all the questions that are given there for you to familiarize yourself with this type of question. Then we use the equations to solve the problems. I'm going to repeat it again. Every time when we are dealing with conservation of mechanical energy, learners, we must always use the formula for mechanical energy. Mechanical energy initial is equal to the mechanical energy at the final. So please guys, let's use the correct formula and use the correct substitutions, because you are given the table of formulae during the exam. So that take that to your advantage and use it to the full for your benefit. Now, we're now going to talk about power. Power, it is the rate at which work is done or energy expended. What I love about this topic, all the definitions that you are expected to know, they are derived from the formula. So when they ask you to define power and you find that it is during the exam and you forgot, remember to take out the table of formula in the middle of the question paper, put it in front of you, and for you not to forfeit that 2 marks for power, you just go to the formula. The formula for calculating power, you know, your teacher did teach you that it is equals to P is equals to W over delta T. Not forgetting P, it is a capital P. Now, with this formula, you will be able to derive power. Every time when you see the formula and delta T, it is the denominator, it is in the denominator, you start by using the word rate. So which means power is equals to the rate at which work is done. So looking at the formula here, we have delta T in the denominator. So we know that our definition will start with rate, and then we say the rate at which work is there in the numerator, the rate at which work is done. That is how we define power or energy expended. So I'm just showing you how to write the definitions, because learners tend to forfeit the marks when it comes to the definitions, or most of them you find that they do not write the definitions. So it is important to at least try to collect the marks for definitions. And then we have 2 formulae that we use. Actually, is the one formula for calculating power. P is equals to W over delta T. And then the SI unit for power, it is watts, capital W. So we use capital W for calculate for the SI unit for power. Now we have to do the calculations to calculate power. But now when it comes to power, you must always remember that the work is done by the force. So if you are not given the magnitude of the work done, then it means you will be given the magnitude of the force. So you have to use that work done by that, you have to use that force to calculate work done by that force, and then you will take that magnitude to calculate power. Then you also expected to know the conventions. That's why we also encounter learners forfeit more marks, because now when it comes to the conventions, learners, if you are given kilowatts, it means 1 kilowatt is equals to 1000 watts. And if you are asked to convert power into horsepower, then you know that horsepower is equals to 746 watts, and you divide, guys, you divide. When you convert kilowatt to watts, you multiply by 1,000. Horsepower to power to horsepower, you divide by 746, the magnitude that will be having for power. And then you have to solve problems and put more emphasis on the conventions. Then we also have to perform calculations using PAV is equals to F times velocity, average velocity. So this formula, we use it when we are given the constant velocity. So but the units are still the same. For power, it's still watts, force, it is still newtons, and velocity, it is still the meters per second. So now you can use the table, the mechanics terms and definition booklet to do the calculation. So I'm not going to go through that because I want us to go through almost all the questions. And then remember, now I am just highlighting the things that you do so that you don't forfeit the marks during the exam. Now let's move on to elasticity. Elasticity is also a topic on mechanics. Learners, I want you to pay attention to the definitions on this topic. There are so many definitions to such an extent that you'll end up being confused. But for you not to confuse yourself, just familiarize yourself with the definitions that are given here. Number one, you need to know all these definitions on page 33. So please go through each and every definition. And remember now, when we mark, we look at the keywords. So if one word is not there, like for elasticity, the word property is not given, you will be penalized. And looking at the definitions here, most of them, they are like more or less the same, because the last part where it says body regain its original shape and size when the deforming force is removed, you will find it on elasticity, you will find it on perfectly elastic body, you will find it on perfectly plastic body, and also you will find it on the restoring force. So the last statement, it is familiar, so you must know it. And then the first part, just know that for elasticity, it is a property of a body by virtue of which the body regains its original shape and size when the deforming force is removed. And then for an example, when we are dealing with the bending of a branch of a tree. Let's say when you bend the branch and that branch does not break, it will go back to the original shape and size when you leave it. But if you break it up to the point where it starts to break, now it is no longer body that has regained its shape, because now it will be broken. So elasticity, it is it's when a branch, it is not broken after you bend it, and then it must go back to its original size and shape. Then we also have perfectly elastic body, which is a body which regains its original shape and size when the deforming force is removed. For an example, a balloon, we know what is a deforming force, most, and a piece of rubber. So those are what are the examples of the perfectly elastic bodies. But during the exam, that's where you'll be asked to give the perfectly elastic bodies examples. So please make sure that you don't confuse the perfectly plastic body with the perfectly elastic bodies. So number one, the examples they are also given on the examination guideline. The first one, it will be the quartz fire in guitar strings. So that quartz fire in guitar strings, it is also given there, but you will forfeit the marks if you leave out, if this part, the quartz fire, is not given. If you just write the strings, then you forfeit the marks because you will be penalized. It is written as the quartz fire in guitar strings. And then Another example is phosphorus bronze in springs and cables, and elastic or rubber bands, string in a bow, a trampoline. So these are the examples that are accepted during the exam. So please do not confuse the examples of perfectly elastic body with the plastic bodies. And remember now, with the first two, if you omit the word phosphorus bronze and just write springs, you'll be penalized, because the word phosphorus bronze must be given on the example, as the example of the perfectly elastic body. Now we're moving on to the perfectly plastic body, is as a body that does not show a tendency to regain its original shape and size when the deforming force is removed. So this one, it won't regain. If you press it and you exert the force on the object and it does not regain its original shape and size, now we know that we are talking about the perfectly plastic body. Number one, wax. If you are working with the wax or playing with the wax, it does not. It is one of the examples of perfectly plastic body. A bread dough, a potty, the one that we use for windows, an art clay. So those are the examples. These are the examples that are accepted for as the examples of perfectly plastic bodies. So please know them by heart. We cannot afford to forfeit the marks for these. Are just a recall. Just know them. Just remember them, and then do not practice. Write them down so that you're not confused. Then we have what we call the elastic limit. Elastic limit is the maximum force that can be applied to the body so that the body regains its original force completely after the removal of the force. So an elastic material can be stretched or compressed so much that it will not return to its original shape but remain distorted. That's when we say the material has reached its limit. So which means I made an example earlier of the branch of a tree. The branch of a tree, when you compress it and then it goes back to its original shape and size. Now you say, no, okay, that one is a perfectly elastic body. But now the moment you compress it and it breaks, which means it is not returning to its original shape. So which means by breaking, the virtue of it breaking, that means it now has reached its limit. That's when we say we now have the elastic limit. The body has an elastic limit. So when stresses up to an elastic limit is removed, the material resumes its original shape and size. So those stresses we are talking about stretched and compression. So, and then when you stretch or compress beyond the elastic limit, that will cause the material to deform without returning to its original shape. So that's when it is the branch is broken, it cannot be returned to its original shape and size. Now we have stress. Stress is an internal restoring per unit area of a body. I told you earlier that there are so many definitions that you must familiarize yourself with. Now the SI unit for stress, it is Pascals, SPA, or Newton meter square, or Newton square meters per square meters. And then we use the formula of stress is equals to force over area. What I love about this table of formulae, this formula, that both of them, they are given during the exam. So in case you don't know, or you don't know what is the symbol is, this formula, it is also given. So rather you write either one of them instead of you writing any other formula that you can think of. And then now when it comes to the area, it depends on the body that is given. You must be able to calculate the area if it is not given. So it is important to know which formula must I use to calculate the area of a rectangle, the area of a circle, or the area of a square. So here are the formulae from the table of constants that are given. For the area of a circle, either we use A is equals to pi r squared, this is the radius, and then or A is equals to pi d squared over 4. So you can use either one of the formulae for calculating, in case you are given the circle, for calculating the area. And we know that D stands for the diameter and the radius also stands for the meter. And then it is radius, R stands for radius, and the units are in meters, but for area it is in square meters. And then for calculating a rectangle, we know that it is the rectangle is a product of the length and width. So which means it is A is equals to length times breadth. So these are given. You will be given the length and the breadth. So you are expected to calculate the area of a rectangle before you calculate stress. Okay, so it is important to know, guys, this formula. Then moving on, we have what we call a strain. A strain is a ratio of a change in dimension to the original dimension. So which means now we are dealing with what? We are dealing with the change in length over the original length. So the change takes place in length, volume, or shape due to the application of deforming force. So there is no SI unit for strain. The reason is because the strain, remember we have the length in the numerator and the length in the denominator, so the units will cancel each other out. That is why there is no SI unit. Then we use the formula strain is equals to change in length over original length. So these two formulae are given during the exam. So when you forget, because the question will say calculate the strain or calculate the stress, then you just go to your table of constants and you will do the calculations. You substitute, and remember earlier what I said that the challenges that we are facing is that with the conventions, our learners cannot or are struggling with the conventions. Okay, so let me show you the example. Okay, now you must note that strain can be expressed as a percentage, or like for example, if stress is equals to 0,1, then the percentage will be 0,1 times 100, which will be 10%, in case you are asked to express the strain as in percentages. Now I just want us to take a look at page 35. I'm using this book so that I know each and every one of you did receive the book. So I'm using it so that you are also going to use it, and there are answers at the back. So you're not going to go through the answers, you're just going through the questions, and then during your preparation you'll use the answers. On question 3, on page 35, it says you are given a 15-meter marble column of a cross-sectional area of 3 meters square, support a mass of 15,000 kg. So what is important here? You are given two magnitudes here. You must know, if I'm given 15 meters and 3 meters square. This unit, this 3 meters square, what is it for? This one, what is it for? Okay, so obviously this one, because we know that the unit for area is meter square, so you are given the mass, you are given the area, and you're also given the length. So now, and also they say the column measures 14,7 meters after the load is applied. So now when they apply the load, it means now they are including the deforming force. Now 3.1, it says define stress of a body for 2 marks. we know what is the stress of a body is, and then calculate the stress within the column. Remember, I showed you how to approach the question. So you'll write your data, you'll choose the correct formula. But for you to get 1 mark for the correct formula, you must attempt to substitute. If there is no substitution shown, it means you're going to forfeit that 1 mark for the formula. So just attempt to substitute. Now you'll have that 1 mark and then 1 mark for the substitution. And then the other one, it will be 1 mark for the final answer with the correct SI unit. Then 3.3 says define strain and then calculate the strain of the column for 3 marks. So you can get this 10 marks if you prepare yourself very well. And look at question 2 also. There's also define strain and also calculate the strain in a bar. Define a plastic elastic body and give 1 example for 3 marks. So you just have to sit down, prepare yourself. You can get this 13 marks. State Hooke's law in words. So all these calculations, you just need to go through them, each and every one of them, and then so that you get this marks. Just take a look at question 6. With question 6, there are so many. Let's take a look at the definitions that are asked here. The first one, they ask you to define stress and deforming force. And also, state Hooke's law. Define strain. Define elastic limit. So we have how many? 10 marks only on definition. So it is important to learn your definitions. Now we are going to talk about Hooke's law. So Hooke's law states that within the limit of elasticity, stress is directly proportional to strain. Remember, guys, for you to get 2 marks for stating the law, you must not omit the keywords. The keywords here, we are talking about within the limit of elasticity and also stress is directly proportional to strain. Then you'll get full marks. So we don't want you to be penalized because of smaller nyana things. And then the Hooke's law says stress, it is inversely proportional to strain. So which means when stress increases, then strain will also increase. When stress decreases, strain will also decrease. So with that, we have the formula that we use to calculate the constant, the modulus of elasticity as stress over strain is equals to capital K. So capital K, it is known as the modulus of elasticity of a material of a body. So capital K, the SI unit for it is in pascals or Newton per square meters. Then we use these calculations to calculate strain, stress, modulus of elasticity. So which means there are 3 calculations, there are 3 formulae, excluding the ones for calculating the area, that you must pay attention to. So, and then from here, the other thing that is also important are the conventions. Before we move on to viscosity, the conventions, when we talk about the conventions, it is important to know your conventions. And at the beginning of these pages, that's where they have indicated the conventions. So it is important for you to go through them and familiarize yourselves with the conventions. And then remember now, what will lead you to help to write the correct conventions? That's when you write down your data and then know your SI units, the one that are accepted for each physical quantity. We're just going to take 2 minutes break so that I drink water and then we'll continue. Let's continue from where we left off. Now we're going to continue with the viscosity. We're going to start with viscosity. Now let's take a look at viscosity. What is a viscosity? Viscosity is a property of the fluid to oppose relative motion between 2 adjacent layers. This is the definition of viscosity, but in a simple terms, we say viscosity, it is a resistance of a liquid to flow. Remember now, we have different types of liquids. We have an oil, we have water, we have a syrup, we also have, let's say, cooking oil or motor oil. So these three liquids that I've stated there, they are different. So when you put them on the ground so that they can flow, each and every one of the liquids will flow according to the viscosity that it has. So the substance with a high viscosity will flow slow, and then the one with the smaller viscosity will flow faster. Like water, is the viscosity of water is very small, so it just flow faster. But now syrup, the viscosity of the syrup is very high compared to that one of the motor oil. So these two substances, they both have viscosity, but the viscosity, it is different. So what makes that, what is that viscosity? It is the resistance of a liquid to flow. Now we're going to talk about the effect of a temperature on viscosity. Remember now, you need to know this thing, the effects of temperature on viscosity. How does the temperature influence the viscosity of the substance? Number one, the type of packaging that is used for different materials. Remember now, how do we package the material is important. If you take a motor oil, the motor oil, you won't find the motor oil in a packaging like the one that we use for toothpaste. And you also won't find the water being packaged in a can. So the type of the packaging that is used for different material also have an effect on the temperature of the viscosity. Number two, where to market products most successfully. Remember now, our climate is not the same. When you have to go to Europe, you'll find most of the time it's cold, while in South Africa it is warm. But when you go to Nigeria, it is very hot. So the packaging and also the marketing of the product is also important, because it affects the viscosity of the substances. So number three, remember now here we are dealing with the product, the substances. So how the production processes are designed. We cannot design the fluids the same depending on the different climates. So when they design the production of this, or when they process the fluids, it is also important on where you are in the world. Now, the transportation also, how the transportation processes are designed. So how are these things going to be transported? Will they be still in the same quality when they arrive to the consumer, or will they change? So when they transport, they pay attention to the following also. Now, with the temperature and viscosity, we also need to know that the change in temperature will always influence the intermolecular forces of the substances or of the liquids. We know that the liquids do have the intermolecular forces. Then when the intermolecular forces decreases, that means the temperature will increase. So they are inversely, the relationship is that they are inversely proportional to one another. Now, and when the temperature increases, we will have the smaller resistance, which will lead to the viscosity being decreased. So the temperature and the viscosity also, they are inversely proportional to each other, because when temperature increases, the viscosity will decrease. Now, let's talk about the motor oil grades. The motor oil grades, they are called the multi-grade oil in an engine. Okay, so an engine of a gear oil must fulfill two viscosity specifications. So in the engine of the car. Now we are talking about the car, because the cars, the trucks, the buses are using the multi-grade oil. So there are two specifications that must be fulfilled by the engine of a car or a bus or a truck. Number one, the specification is that it must lubricate the moving parts. That is the oil. It must lubricate the moving part. Remember now, as the engine is as the engine functions, it must always, the parts must move smoothly. There must not be any problem with the movement of the parts, and also it must cool the moving parts. So as the parts are moving, they are lubricated and they are also being cooled down by what? By the multi-grade oil. And also it removes the high temperature deposits. Remember now, as the parts are moving, the temperature will increase. So the oil will remove the high temperatures. Okay? And also it will help to seal the pistons in the cylinder of an engine. So what is important is that without these functions, the engine will run for only few seconds before it overheats and then seizes. So it is important to ensure that you have an oil in the car. So you take this to the exam. There must always be an oil, and you know the specifications of multi-grade oil. Now, we have when you get to the garage, you'll find that there are different types of the oil. So the containers are written. There are something that's the numbers that are written on the container. So we're going to talk about the examples of information on a container with a motor oil. Number one, you will find that the motor oil is written SAE 10W hyphen 30. So SAE stands for Society of the Automotive Engineers. Then when the numbers describes the behavior of motor oils under low and high temperature. So in the motor oil, there will always be two numbers, but between the two numbers, there will also be a W in capital letter. Now we're going to talk about the numbers with W. What does 10 indicate? 10 indicates the viscosity as rated at 0 degrees Celsius. So we know that when the temperature it is plus or minus 0 degrees, it's cold. So 10 means that the oil that can be used at 0 degrees Celsius will be 10. And then W stands for winter. So 10W means temperature at 0, the viscosity at 0 degrees Celsius during winter. Then 30 represents the viscosity as rated at 100 degrees Celsius, which means now we're talking about when it is hot. Okay, now remember, when you get to the garage, there are different types of oils. So you will have SAE 10W30, and you need to know that it has less viscosity than SAE 20W50. Okay? Then this one of 10W30 has less viscosity in cold weather when the engine is not running. So during winter, the 10W, it is the viscosity, it is less when the car is standing there, is not moving. And then the one for 20W50 means 50 means oil stays thicker in higher temperatures than the one with lower number like 30. So the difference here now is that you need to know which oil is suitable for which temperature. So during winter, do you think it will be advisable to use 20 20W or 10W. So the examiner will ask you. So right now you need to know that 10W, it is the one that is suitable to be used in winter, because now remember in winter it's cold. So the temperature, when it decreases, the viscosity will increase. So we must have less viscosity as much as we can. So that is why it is important to start the car to warm the oil before you move with the car. Now we have reached the end of this lesson. We'll continue after 15 minutes with hydraulics. Thank you. Welcome back, boys and girls. Let's continue from where we left off. We're going to start with hydraulics. So hydraulics is still part of mechanics. What is hydraulics? Hydraulics is defined as a field in applied science and engineering dealing with mechanical properties of a fluid, or it is also known as the study of mechanical properties of fluids. So which means we are dealing with the solids which have, and we know that the solids have which have the definite volume and shape. Liquids have definite volume but no shape, and gas has neither volume or shape. So what we're dealing with here, we're going to talk about the solids and shapes and liquids, sorry. Then the hydraulics is used for generations, control and transmission of power through pressurized liquid. So the liquid is being pressurized, so they generate or they control and transmit power through the hydraulics. And also the liquids used to transfer the force are usually mineral or synthetic oils. So the other thing that is important, you also need to know what is a thrust. Thrust is the normal force exerted by a liquid at rest on a given surface in contact with. So, or you can say the normal force acting on the area or a surface, which is the thrust, the definition of a thrust. So there is a different way a surface force acts on a liquid and on a solid. Now, for a solid, there is no restriction on the direction of a force. But for a liquid, the surface of a force must always be at right angle to the surface. So that is the restriction. And then we also have a pressure at a particular point, that is the thrust acting on the unit area around that point. Or you can say pressure, it is the force exerted per unit area. Then the SI unit for pressure, it is in pascals or Newton per square meters. Then we also calculate pressure as pressure is equals to force over area. Therefore, it is measured in pascals, or we use the equivalent SI unit, Newton per square meters. It is also acceptable. Now, when you're dealing with pressure exerted by the solid object, and then when the pressure, when we press our fingers against the wall, no lasting marks are left. So like when you press on the wall, obviously there won't be the mark that is left. But the same figure pushing a thumbtack may damage the wall. So in case the wall is not a cement, then if it is a wood, if you press on it, it will the thumb might damage the wall. So although the force may be the same, but the sharp point that we concentrate in is the small area where there is a damage that has been left. And then so now we are able to use the following conventions in all calculations of pressure. 1 atmosphere or 1 atm will be equals to 1,0110 times 10 to the power 5 pascals. 1 bar will be equals to 10 to the power 5 pascals. and then 1 torr is equals to 133 pascals. So which means sometimes when we do the calculation, you'll be asked to convert the pressure into atmosphere or bar or torr, or you are given the torr, the atmosphere or the bar, and then convert it to pressure. So you need to know these magnitudes during the exam. Most of the things here you have to learn and know them. So now we're going to talk about the pressure in liquids. Then with the pressure in liquids, it is easier to measure the pressure in liquids because in a liquid, particles are in a random motion. We remember grade 10. And then these particles collide with one another and with the walls of the container and objects in the liquid. Remember, now we are dealing with the liquid, so they are in a random motion. So as the particles collide, they exert force on the wall of the container perpendicularly to the surface area. So when the pressure increases, these particles collide more frequently, and then they will increase the pressure on the objects in the liquid. So, and again, the particles can also move in any direction. So now we are dealing with the pressure in liquid. Now, what is a fluid pressure? A fluid pressure is a liquid which flows under a shear force and conforms the shape of the container. So now the fluids will exert pressure on the container and the objects in the fluid. Then we say a fluid pressure is defined or it is directly proportional to the density of the fluid. So we use the following formula to calculate the fluid pressure. P is equals to PGH, whereby we know that P is equals to stands for pressure, and then small p, actually it is not a small p, it's like a p without the sharp point, and then it is a density. Then we also have G for gravitational acceleration and H for height. So we only use this formula when we want to calculate the fluid pressure or the pressure in liquid. Okay, then we have what we call the Pascal law. So with the Pascal law, I want us to go back. Before we talk about the Pascal law, I want us to go to the formula that we use for pressure on any surface. That is where we say P is equals to F over A. Now let's talk about the Pascal law. The Pascal law states that in a continuous liquid at equilibrium, the pressure applied at a point is transmitted equally to the other part of the liquid. Now, sorry guys, okay, I want us to take a look at this two formula here for hydraulics. Remember I said on this booklet on page 40, that's where you'll find the summary of hydraulics. So we have two formulae that we just spoke about, the first one and the second. So we have two types of pressure. We have the pressure in liquid and pressure on any surface. So this formula, we only use it when we want to calculate the pressure in liquid, and this one we use it for calculating pressure on any other surface. So this one, it is specific, whereby this symbol stands for the density of a liquid in kilogram per cubic meters. And then we have pressure, we have gravitational acceleration, which is constant as meter per square seconds, and also we have the height in meters. So this is the height of the depth in liquid. But with this one, we have pressure in pascals, force, capital F, which is the force in Newton, and also the area in square meters. Remember, this formulae are given during the exam, so we expect you to know to use them and copy them as they are, because if you write them down and you find that you do not copy the formula correctly, you will be penalized. So Pascal law, it is the law that is basic. This is the basic principle that causes hydraulic power in heavy construction machines at work. And then you also expected to know the application of Pascal law. Guys, this question, it has been asked since from 2018. The first time you were writing the first time technical science was written in 2018. They've been asking learners to write the applications of Pascal law, and you find that learners are still writing incorrect applications. So please pay attention to these ones that I'm going to give them to you, because they are the ones that are acceptable. Number one, it is the bulldozer working system, hydraulic power brakes on automobiles, dentist chair. You know, what is so sad is that you can see that the learner wants to talk about the dentist, but because of the language, you'll find the learner writing density chair. And the moment you are talking about density, then you forfeit the marks, because dentist and density are two different things. So guys, the examples, pay attention to these applications. And hydraulic lifts used to lift heavy loads, car jacks, bus doors, and etc. But with etc, you must be careful. Remember, you must make sure that you write the correct applications of Pascal law, because the moment you write the incorrect one, you'll forfeit the marks. And this is just a recall question, and it has been there for final 2018 final and also supplementary in 2019. Also in the final exam 2019, the question was still there. So please learn these applications of Pascal law. Now, we also expected to do the calculations of hydraulic lift, and also you must know the important applications of Pascal's law we just spoke about. I just want to put more emphasis on the applications and calculations. You know, the sad part when it comes to the calculations, that learners are given, you are given the formula, but because you don't know the symbols, which symbols represent which quantity, then that's where you'll find that learners are just taking any equation that think will be correct. And in that way, if the equation, when we mark, if the equation is incorrect, you get 0. And while you can still get marks, at least for the formula, then you will know that you will attempt to substitute, and you'll get that 1 mark for the formula. Then hydraulic lifts are also used to lift heavy loads. Now, what is important here? We say because the hydraulic lifts are used to lift heavy loads, like at the scrap yards where they crash the cars, they use the hydraulic lifts. So now, when there is a force of magnitude F1, it is applied to a small piston of surface area A1. The pressure will be transmitted through the incompressible liquid to a larger piston surface area. Now let's take a look at this picture. Still on page 40. This is what we are talking about. This is the small force that is being exerted, and here is the pressure in this area. Then this pressure, the force will be exerted, and it will be the same throughout. The pressure will be the same, not the force, not the area, because if you see the area, it is small, this one and this one, the area, it is big, and the force obviously will be larger and the force will be smaller, but the pressure will be the same. So for the pressure for F1 will be equals to the pressure for F2. Now I said the pressure transmitted through liquid to a larger surface area A2. So this is because the pressure must be the same in both sides. But what is not the same, it will be the force and the area. So that's when we say, because we know that from P is equals to FA, then if for force 1 and area 1, we have the pressure, and also for force 2 and area 2 we have pressure. That means both force F over A and F2 over A2 will be equals because they will be both, they will have the same pressure. So that's when we have the formula F1 A over A1 equals to F2 over A2. This is due to the pressure being the same in both sides. So whereby the A2 will be greater than A1 in this case. Then we use the calculations to do, we have to do the calculations. So we have different types of questions. You can take a look at from question 1 up to the last question, whereby you will have the two forces with the two areas. The other one will be bigger, the other one will be smaller. So if they are like this, we know that the pressure is the same throughout, and then you are able to do the calculations. Also depending on what you are given. So let's take a look at the areas that are given. So here you are given the area, so there's no need for you to do the conventions. But take a look at question 2. With question 2, you are given the areas with in centimeters. Number 1, you must pay attention to the SI unit that we use for the areas, which is meters. So after doing your calculation, you'll have to do the convention. So which is important in this question, whereby if you don't do the conventions, you're going to forfeit the marks. For instance, let's take a look at this. The radius that is given here, it is 20 millimeters. So you're not given the area. So which means you are expected to do what? To calculate the area. So by calculating the area, like let's take a look at question 4.1. They ask you to calculate the radius of piston 2 for 3 marks. So the formulae are there. They are given for calculating the area. What is important before you do the calculations, make sure that you convert millimeters to meters. So it is important to pay attention to the conventions. I want us to take a look at this one. This was 2019 question. Looking at the force, how it is given. This force is given in kilonewtons. So which means you must convert kilonewtons to newtons. Take a look at the diameter of A and B. They are given in millimeters. So which means, what are you going to do? You are expected to convert the diameter and also the force y, because you'll be asked to calculate F2. So guys, please pay attention to the units and the conventions, and make sure that you do the correct conventions, because that's where most of the learners forfeit the marks, because they tend to forget to do the conventions. Okay, now moving on from hydraulics. Remember again, I said the area of A1 will be great, A2 will be greater than the area of A1. And the other thing, guys, the subscripts on the formula, please don't leave them out, because if you leave them out, that's when you yourself, you end up being confused, because now you don't know F1, which side is F1, which side is F2 for yourself also. And you will be penalized once for omitting the subscripts on the formula of when calculating the hydraulics lift. Now we're moving on to capacitors and capacitance. What is a capacitor? A capacitor is a device that is used for storing electrical charge. And then the capacitor, it is also made of two plates separated by a dielectric. So which means for us to have a capacitor, there will be some of the capacitors, they have air, others they have a material like a cardboard or liquid. It depends on the type of the capacitor that is being used. Now you also expected to give us the examples of capacitors used in technology. Number 1, the capacitor is used in filter circuits in power supplies. Number 2, as the separation of frequencies between the woofer or the speaker and the tweeter. So those who like to DJ, they know what is happening inside the speaker or the tweeter. Then also it is used as the power factor correction or improvement in electrical transmission systems. Now the capacitor, it has the capacitance. So we have what we call the capacitance of a capacitor as the amount of charge it can store per volt. Now the SI unit for capacitance is capital F, or we can write it as farad. So the SI unit, the symbol, it is capital F, farad. Then we have the formula that we use for calculating the capacitance of a capacitor as C is equals to Q over V, whereby we know that C stands for the capacitor of the capacitance, so the capacitance of the capacitor, and Q, it stands for a charge that is measured in coulomb. The SI unit for charge is coulomb, and also we have the voltage in volts. And then now we know that 1 farad will be equals to 1 coulomb per volt. So the coulomb per volt, it is an equivalent SI unit, but when you do the calculations, we expect you to give us the SI unit for capacitance as farad, not as coulomb per volt. Now also the capacitance can also be expressed as C is equals to the permittivity of a free space times K times A over D, whereby A is the area of the plate. Remember now, with the capacitor we have two plates that are parallel to each other. So the A will be the area of the plates, and D will be the distance between the plates, and K is the relative permittivity of a free space, and that symbol, it is the permittivity of a free space. So K, it is the one that stands for dielectric, so we can use it for a dielectric. Then the formula, we can also write it without that K. So in case the dielectric material is air or vacuum, or it is not mentioned, so you can also use this formula whereby K is omitted, or K will be equals to 1. You won't be penalized to use any formula between the two, but as long as you must pay attention to whether you are given the dielectric or not. So if it is not given, you can use the second formula. If it is given, you must also use the first one and also know what is the magnitude of that dielectric. So in case of air, if they say air is used as a dielectric, then you will know that K will be equals to 1. So we want you, or we expect you to state the factors affecting the capacitance. Number 1, the surface area of the plate. Okay, so let's do this. When we talk about the surface area, what are we talking about? Remember, capacitor, it is two plates which are parallel to one another. So when we talk about the surface area, remember this plate, I don't know how to draw, but I want to draw like something like this, where it shows that there are two plates parallel to each other. So we are talking about the surface area of the plate. So you must pay attention to the surface area of the plate. So what you know, that the greater the surface area of the plate, the greater the capacitance of the capacitor, which means, remember, a capacitor, it is used to store electric charges. So more charges will be stored if the surface area of the plate is big. Then the other thing again, it is the distance between the surface area. Sorry, the distance between the capacitor. So let me make an example. Here we have our capacitor, So paying attention to the first capacitor that I've drawn, the distance it is much shorter, and then the second one, the distance it is longer. So which means the smaller the distance, the higher the capacitance, or the capacitance of the capacitor will be. Which means when you put the plates close to each other, the capacitor has the ability to store more charges, but if you put them far away from one another, then the capacitor has the ability to store less charges. That's what they mean as one of the factors of the capacitance, the distance between the two plates. Number two, the types of dielectric that is placed between the plates. So the material that is, which is the dielectric, the one that is placed between the plates of the capacitor, and it can be any form. It can be air, it can be plastic, it can be glass, or it can be mica. But what is important is the greater the magnitude of the dielectric used, the greater the capacitance of the capacitor will be. So which means if you use the number, that K, if it keeps on increasing, it means more charges will be stored. Then you are expected to do the calculations based on the capacitor of the capacitance. And the other thing that I must also indicate is that when you are doing the calculations, make sure that you substitute directly to the formula, because when you swap around the substitutions, you're going to be penalized during the exams. Now let's talk about electric circuits. From grade 11, you are expected to be able to state Ohm's law. So this Ohm's law was done last year when we were in grade 11, and it states as follows: as the potential difference across the conductor is directly proportional to the current in the conductor at constant temperature. Now, in grade 11, you were also taught about the relationship between the current, the voltage, and the resistance at constant temperature using simple circuits. So with this topic, we expect you to be able to interpret the circuit and also be able to tell us what is the relationship between the current, voltage, and resistance using Ohm's law. Now, you will be given the series combination. So with the series combination, remember, we now want to know what is the relationship between current, voltage, and resistance according to Ohm's law. Number one, you must pay attention to the connection of the resistors. So the resistors must be in one line. So when they are in one line, we say they are connected in series. Now, in this case, that will lead to the total resistance being very high. What do I mean by that? In a series combination, your resistors will be connected in one line. This is what we mean when we say they will be connected in one line. Let's say we have 1 ohm, 2 ohm, and 3 ohm. So when you have to calculate the total resistance, remember the formula is given R1 plus R2 plus R3, because you have 3 resistors, and then you substitute 1 plus 2 plus 3, so which means the total resistance, it is now 6 ohm. So the resistance in a series circuit will be very high, or in a series combination. Now the current is the same throughout. Let's say, let me try to draw the circuit here. Okay, now let's say you are given this kind of circuit. Yeah? Then we'll have the potential difference of 2 volts. We have 1 ohm and 2 ohm. Then the current will be 1,5 amperes. Okay. because now these two resistors are in series, which means the current for resistor A1 will be the same as the current for resistor 2 ohm. So the current for this resistor here will be 1,5 ampere. This one will also be 1,5 ampere. So that is what is important. So at this point, we say the current that was flowing through the circuit, it was 1,5. So because now we have a series combination, we'll have 1,5A and also 1,5A. So here the current will be 1,5 at that point. Okay, now moving on, the potential difference. Now with the potential difference, we say in a series combination the potential difference is divided, which means the resistor with the bigger resistor will have more voltage. So let's say we have the EMF is equals to 2 volts. So which means the potential difference in the circuit, external circuit, it is 2 volts. So at this point, we have the potential difference of 2 volts. But at this point, the potential difference will be 0. So which means the potential difference will be divided between the two, not forgetting that this one will have more potential difference because it is bigger. This one will have a less potential difference, this resistor, because it is small. So what do you do for you to be able to determine the magnitude of the potential difference? Then you'll have to use Ohm's law, which is R is equals to V over I for 1 ohm resistor, and then the potential difference we wanted, and then the current is 1. Remember, it is the same, and then we have 1. So the potential difference, you do the calculation and you make V the subject of the formula. Now with a parallel circuit, and then here the resistors are in parallel. What do you mean by resistors being in parallel? These resistors will be on top of each other because they are in parallel. So this is what we mean when we say the resistors are in parallel. So you will still have 1 ohm resistor and 2 ohm resistor. Then the total resistance will be less in a parallel combination. How will it be less? Remember, now you have to calculate the 1 over R, which means we'll have 1 over R1 plus 1 over R2, and then we'll have 1 over 1 plus 1 over 2. So when you do your calculation, you'll find that your final answer, you must not leave 1 over RT as it is, it must be RT. So after doing the calculation, 1 plus, which is 2, 2 plus 1, which is 3 over 1. You don't leave it as 3 over 1, it will be 1 over 3. So if it is 1 over 3, it will give us 0,333 up to infinity. But remember, the rule says round off your final answer to 2 decimal places. So this is how we calculate the parallel combination. This is how we calculate the total resistance in a parallel combination. Then the current is divided. So at this point, if we have the current of 1,5, at this point, the current that will move to 1 ohm and the other one must move to 2 ohm. So the current must be divided between the two resistors in a parallel combination. But remember, in a series combination, we said that the current is the same. So here the current is divided in a parallel combination. Then the potential difference will be the same. So the bigger resistor will have the less current and the smaller resistor will have the bigger current. The potential difference will be the same. So if the potential difference was 2 volts, then it means that 1 ohm and 2 ohm resistors will have 2 volts. But in case whereby we have a series circuit and, let me make an example. In case whereby we have a series and parallel combination like this, and we have the potential of 2 volts. Remember, now we have this the resistor that is connected in series, we have the resistor that is connected in parallel, and so we said the potential difference will be the same, and the potential difference in a series combination will be divided. So what does that mean? It means the total potential difference cannot be more than 2 volts. It must be equal to 2 volts. So the potential difference, the 2 ohm, will take a certain amount of potential difference depending on what is the magnitude of the ammeter. Remember, the current is the same. Then let's say we have 2 amperes, so which means this one will just use the formula to calculate the potential difference that will be used by the 2 ohm resistor. Then which means we'll have 2, and then we have our V, which is we want to know, and then we have 2, so V will be, hey guys, my magnitudes are not correct, but I'm trying to, let me make this 4. I'll make V the subject of the formula, but what is important here, certain amount of potential difference will be used by 2 ohm resistor that is connected in series, and the one that is left, it will be used by the parallel combination, because that's where the potential difference are the same in a parallel combination. But when you add the potential difference for 2 ohm and the potential difference for parallel combination, must give you the EMF of the battery. Now, you are also expected to state the difference between ohmic and non-ohmic and conductors, and give examples. Number 1, a conductor. What is a conductor? A conductor is a substance that allows current to flow through it. However, the current, those conductors, we classify them as ohmic and non-ohmic. Remember, this topic was done in grade 11, but if you go through the examination guideline, it states this point that I'm talking about. Now, the ohmic conductor, it is a conductor which obeys Ohm's law all the time. That is an ohmic conductor. We say it has the linear relationship between the current, voltage, that is, the resistance will remain the same. So when the resistance is the same, it means now the conductor is obeying Ohm's law, and will be classified as an ohmic conductor. Then a non-ohmic conductor, it does not obey Ohm's law all the time. So which means it has the non-linear relationship between the current and the voltage. So that will lead to the increase in the resistance when the current increases, or the decrease in resistance when the current decreases. Then you also need to know what is an EMF, but we're not going to, they do the calculation. So EMF, it is the source of energy, like we just made an example. You will be given the magnitude of the battery, the voltage of the battery, so which means the potential difference of the battery will be the EMF. So we must also be able to define EMF as the source of energy from the battery that can cause the current to flow in an electric circuit or a device. So now it refers to the voltage measured across the terminals of the battery when the switch is open. Remember again, when the switch is open, the potential difference is the same. Okay, now here with the internal resistance, you can only define the internal resistance, but without doing the calculations. So you're not going to do the calculations. So The internal resistance, it is the resistance inside the cell when the current flows through it. That is only what you need to know about the internal resistance. So again, internal resistance of the battery, it is made of chemicals and metals. So these metals or these chemicals can cause the battery to have resistance to flow of the current through it. So internal resistance reduces the voltage and the current available to the external circuit. So it is not constant, it increases as the battery is used. That is all you need to know about internal resistance. You don't do calculations on internal resistance. Now we also have what we call electric power. Electric power can be defined as the rate at which work is done or energy transferred, or electrical energy is converted in an electric circuit. And power, it is measured in watts with the symbol capital P. Make no mistake of writing a small p. Now remember, now power has large readings, so they are written as kilowatts, or for 1 kilowatts for 1000 watts, or 1 million watts as 1 megawatts. So when you see the word megawatts, you need to know that we have 1 million watts. So with if the power is the reading is very small, then we use 1 milliwatts for 0,001 watts. Then we can also calculate electric power using the following formula. P is equals to VI, whereby V stands for the potential difference and I for the current. The second formula, P is equals to I squared R, whereby I is for the current and R stands for the resistance, and P is equals to V squared over R. This one is where the potential difference and the resistance, and also P is equals to W over delta T. So W is the work done over the time. Now we have to deduce that the kilowatt hour refers to the use of 1 kilowatt of electricity for 1 hour. Okay. Now the other thing, with the calculations, you are also expected to calculate the cost of electricity usage given to the power specifications. So which means it will be part of the exam. You have to calculate the cost of electricity. So with the cost of electricity, we know that Eskom, in South Africa we are using Eskom, whereby it is the one that charges us for electricity usage. So they measure the amount of electricity used over a specific time. Then, due to large amount of electricity used, it is easier for household to work with kilowatts per hour to measure electric power usage. So at your house, you use the kilowatt hour because we use electricity at all times. That's why you have stress when we have load shedding. Now, each household, you can measure the power by using the following calculation. So remember, even during the exam, you'll be given an appliance, an electric appliance, and then you are expected, it depends on what you are given, but you must make sure that you have power for you to be able to calculate the cost of electricity. So if the power is not given, you first start calculating power using the formula P is equals to W over delta T. And remember now, power for this one, for this calculation, you're going to calculate power in watts. But when you calculate the cost of electricity, it must be in kilowatts. So we can either use the symbol W or E for work done or energy, and then T, must be in hours. So I don't know how you were taught by the teacher, but what is important, after doing the calculation, you must make sure that you have the unit of kilowatts. Okay, kilowatts hour. So because if the time must be in hours and the work done must be, the power must be in kilowatts. Okay, now, and the work done will be in kilowatts hour. Now Eskom charges each kilowatt hour of energy used at specific tariff. But during the exam, you will be given a specific tariff by the examiner. Will tell you that the specific tariff for that appliance, it is 1 rand 20 or 2 rand 94 rand. So what you need to do, you just have to do the calculations, because remember what I said you need power to be able to do the calculations. So to calculate the cost of energy, you have to use the following formula. Cost of electricity is equals to kilowatt hour times the tariff. But the kilowatt hour, it must be calculated. That is the energy that must be calculated. So you start where? From power. So if you have the power, if you are given the power and the time, you must make sure that power must be in kilowatts and also time in hours, and then you have the energy, and then you have that magnitude. You'll take it and you multiply it by the tariff, and you'll be able to determine the cost of the appliance of electricity of a specific appliance that will be given during the exam. So just go through the previous question papers, go through the textbook, and practice with these calculations. Okay, now you are also expected to know the heating effect of electric current. Okay, when the battery or the resistor and closed switch connected in series, the current will start to flow. So in the circuit, when the switch is closed and then we have the resistor, we also have the battery, then the current will start to flow, and the resistor will oppose the flow of current through it. Then the resistor will start to heat up. Then the heat is produced in a resistor. It is directly proportional to the square of the current flowing through it. So therefore, the resistor, as well as the time it takes for the current to flow through the resistor. Now, the heat that is produced, it is written as W is equals to I squared RT. Remember now, the resistor is connected in series. That is why we are using W is equals to I squared R times T. So in our daily lives, we use many devices where electrical energy is converted to heat energy, like a bulb. A bulb, when you touch a bulb, or a stove, the electrical energy is converted to heat energy. And then when the current passes through a stove or geyser, the filament gets heats up it heated up, and electrical energy will be converted. Now, what is important here, if the resistor is connected in parallel, that's when we'll use W is equals to V squared over RT. Then electromagnetism. I'm running out of time. I'm just going to go faster through it. Remember now, this topic you did not write about on it in September. So it is important to go through it again, revise, study, and understand this topic for electromagnetism. Electromagnetism, what is it all about? It is about the current carrying conductor which produces a magnetic field around it. So remember now, we are talking about the conductor that carries a current. So when the conductor has the current, it means there will be magnetic fields that are produced around it. Now, we also have to determine the direction of the magnetic field using the right hand, around the current carrying conductor, using the right hand rule. So with the right hand rule, we are able to determine the direction of the magnetic field and the current. This is how we use the right hand rule. The thumb will represent the current, and the four fingers will represent the magnetic field. So in this case, the current, it is upward. Remember again, you must always use the right hand. So that's why it is called the right hand rule. So the thumb represents the current, and the four fingers represents the magnetic field. So if the thumb is pointing upward, it means that is the direction of the current. and the magnetic field, the direction of the magnetic field will be anti-clockwise. But if the thumb is the current, let's say the current is flowing downward, so the thumb will point downward and the magnetic field will be clockwise. So that is how we determine the directions using the right hand rule. And also we are expected to draw the magnetic field lines around the conductor. So around the number 1, the straight current carrying conductor, we have the straight current carrying conductor and also the current carrying loop or a wire. So the picture that I've just shown here, that's where we have the the clockwise and anti-clockwise magnetic fields, and also we have a dot and a cross. With the cross, that's when you put your thumb into the book and then the direction of the magnetic field. So that's when the current is downward, and also it will have a cross. And then if remember now you are writing. So when you write, you don't have the conductor in front of you. So you have to use the book. That is why we say the current into the book and the current out of the book. So out of the book, it will be the thumb will be upward, and into the book the thumb will be downward. So it will always determine the direction of the magnetic field. That's how you should draw the magnetic fields around there. This one is for the straight current carrying conductor. Then you are also expected to define electromagnetic induction as the process of generating electricity from motion. Now we have what we call the magnetic flux as the number of fields perpendicular to the surface. And the magnetic flux, the SI unit for magnetic flux, it is in Weber. Weber, capital WB, that is the SI unit for magnetic flux. And that is the symbol that we use for calculating magnetic flux. So it is not written in as magnetic flux, but we use that symbol whereby we have the magnetic flux is equals to B times A, and then whereby that's the symbol, the first symbol, it is for magnetic flux, and then we have B for magnetic flux density, and A, it is for the area of the loop. Now we have to use the above equation to calculate those physical quantities that are given. Now we have to define again magnetic flux density as the number of field lines per unit area. So when we are talking about the density, we are referring to the number of field lines per unit area. Now the SI unit for magnetic flux density is Tesla. So now we are talking about the new units, which is Tesla, capital T for density. And density, the symbol for density, remember it is B. Now we say 1 Tesla is equals to 1 Web per square meters. Now in this formula is still the same as that one. We just made B the subject of the formula. So remember, now we also advise learners not to interpret the formula. Just copy the formula as it is given from the table of formulae, and then you substitute directly to the formula. It doesn't matter whether they ask you to calculate magnetic flux density or magnetic flux, but what is important is that you will still use the same formula. Now also you are expected to state Faraday's law. Faraday's law states as when the magnetic flux linked with the coil changes, an EMF is induced in the coil. So the magnetic of the induced EMF is directly proportional to the rate of change of magnetic flux. If you forget it, then you can remember the formula. You can take it from the formula that when you look at the formula, remember earlier what I said? I said that the moment you see delta T in the denominator, it means we are going to talk about the rate. So in this case, the induced EMF is directly proportional to the rate of the change in magnetic flux. And looking at the numerator, you find that we do have the change in magnetic flux. So just use the formula to state Faraday's laws, and not forgetting that the magnetic flux link will with the coil, when it changes, the EMF is induced. Then when you do the calculations, then you need to know that we'll be given the induced EMF, the first symbol, and then you have N. N stands for the number of coils or the number of turns, and then you have the magnetic flux and the time. Then you must also note that the negative sign indicates that the EMF is in opposite direction to the effect that produces it. Now, we also want you to state Lenz's law as the direction of induced EMF in the coil that opposes the effect that produces it. And also transformers. You must define the transformer as a device used to step up or step down the voltage. Now we have the formula that we use for calculating the transformers, whereby we will have the output voltage of the primary and secondary determined by the number of turns. Guys, the formula is given. You have to copy it as it is given in the table of formulae. And then the other thing that you must pay attention to is that when the transformer increases, the voltage is called step up transformer, which means when the transformer decreases the voltage, it is called the step down transformer. So in a step up transformer, we know that N for primary will be less than N for secondary, which is the number of turns. So primary will be smaller than secondary. So I've spoken about the transformer that decreases the voltage, and then whereby the number of turns for primary will be greater than the number of turns for secondary. And then we also have the generators. With the generators, we have a device that converts mechanical energy into electrical energy. So with the generators, they will ask you to give us the energy conversion. So it will always be mechanical to electrical. So we also have to understand the basic operational principles of an AC generator. So how does the AC generator operate? The coil, remember there is a coil that will rotate anti-clockwise around the central axis, which will be perpendicular to the magnetic fields, and the coil will cast the magnetic field set up between north and south pole at different angles. Remember, now we'll also have the magnets between, the coil will be placed between the magnets. And then the DC generator, how does it work and how does it differ? So DC generator, it uses the commutator, and AC uses the slip rings. And then we also have to know the advantages of current over direct current. Number one, AC voltage can be stepped up or down using transformers. Those are the advantages of alternating current. And also AC voltages can be stepped up, and electrical power can be transmitted over long distances in power lines at low current to minimize the power loss due to heating. Then it is easier and cheaper to convert AC to DC. Remember, with the conversion, you just have to change the component, which is the commutator or the slip rings. Then AC motor can produce high power output, the DC motors. Now you are expected to be able to sketch the voltage, current, time, voltage, time, and current versus time for an AC circuit. So this is how we sketch the graph of an AC. And also you must you are also expected to show the positions of the coil when you when you sketch the graphs. Then also the last one, we have to use the principle of electromagnetic induction to explain how generator works in an electrical power plants, diesel, and to convert kinetic into electrical energy. And then also it is also a magnetic induction. It is used in cars to recharge the battery while the car is being driven, and also in moving coil microphone. So the sound wave makes a coil move. As the coil moves in a magnetic field, a current is induced, and this varying current can be amplified and fed to a loudspeaker. So just know the functions of the component of AC and DC generator. So the function of commutator, it is to ensure that the direction of the current in the external circuit remains the same. Remember now, with the DC, the coil will move in one direction, and with the AC, so the slip ring for AC, it is to ensure that the direction of the current in the external circuit is the same as the direction of the current in the coil. And also it helps for the alternating current for the coil to change the position. That is all. I would like to thank you and good luck for the exams on Friday. I hope and believe that you will ask where you don't understand, ask your teacher, ask your peers, and all the best for the exams. Thank you.